Alright, hello again everyone. So this is the next part of our video series of our Exam 1 solutions for our extra credit for Calculus 2. So we're just going to get right back into it. So question 3, find the volume of the solid obtained by rotating the region R enclosed by the curves y equals x and y equals x squared about the line y equals 2. Using either a shell disc or washer method. So what we're going to do, we're going to use washer method for this, y equals 2. And what I'm going to do here is just right away is I'm going to mark y equals 2 on my graph. Because we are rotating about that axis. Our next step that we want to do when we're sketching the region here, start with y equals x. We're going to draw it a little longer than necessary for right now, but that's our y equals x. Our y equals x squared. Make a point there. And then we'll remake that, okay. Y equals x. Y equals x squared. Okay. And we do have a point of intersection. Now, we can kind of guess what that point of intersection is going to be. However, we're going to go ahead and find it. So, to start, we're going to set our equations equal to each other. So x equals x squared. I'm going to subtract x from both sides. I'm going to factor out an x from here, x minus 1. X equals 1. Okay, so those are going to be our limits. We have a point of intersection at 1, 1. Our next step, what we're going to do, because we need to find out our outside and inside radius. From our line about y equals 2, we're going to draw a line. Just before you hit the line, you're going to stop. Then you're going to draw another line. And then you're going to stop. Now, there's not that much of a difference. But if you see, this one is lower. So your inside radius we're going to have our x be our inside. However, since we're rotating about the y equals 2, we need to subtract to get back to our original starting place, right? So the same thing is going to apply with our outside function. So we have our 2 minus, but x squared, because that's going to be our outside, okay? So our outside, 2 minus x squared, and then our inside is 2 minus x. So now we can set up our integral. So pi from 0 to 1. So our outside function, 2 minus x squared, but we need to square it, minus our inside function, 2 minus x, but we need to square that as well, dx. And now we can go ahead and solve. So pi, the integral from 0 to 1, I'm going to write this in standard form here. So x to the 4th minus 4x squared plus 4 minus x squared minus 4x plus 4 dx. Okay. From here, we just do a little bit of cleaning up. We are left with x to the fourth minus 5x squared plus 4x dx. From here, we can go ahead and do our integration. 1 over 5 x to the fifth minus 5 over 3 x to the third plus 2x squared from 0 to 1. All the zeros, when you place them in for x, will all make 0, so we will just focus on the 1. So we are left with, however, we will still show that this will make 0. Our first part, 8 over 15 minus 0 equals 8 pi over 15 units. And that'll be our answer. Okay, question 4. I'm going to solve the integral of sine square root of x dx. Okay. So I'm going to actually do not a u substitution here. I'm going to do a t substitution, and you'll see why once I get later on down, because I'm going to have to do another integration by parts. This problem is an integration by parts piece, but to get there, we need to do a u sub first. So what I'm first going to do, instead of the u sub, we're going to do a t sub. So our t equals our square root of x. Our dt equals 1 over 2 root x dx. To get dx by itself, which we need, we're going to multiply each side by 2 square root of x. So we're going to be left with 2 square root of x dt equals dx. Okay? But now keep in mind, our square root of x is going to be changed by a t. Okay? So sine t times 2t dt. From here, what we'll do to make this look a little nicer, we're going to pull out this 2, with it being a constant. Sine t times t dt. And now we have a nicer looking form to where we can do our integration by parts here. So integration by parts formula states the following. The integral of u times dv equals u times v minus the integral of v times du. Alright, we'll slide this up here just to help out. Okay, so from there, we need, I'm going to do this in a different color. So I need a u, I need a du, I need a v, and I need a dv. So in this scenario, we're going to make t our u and sine t our dv in this situation, okay? T1 dt. Our dv is going to go right here, sine of t. And now we're going to integrate instead of differentiate now. So what is the integration of sine t? It should be negative cosine t. Okay, and then what I'm going to do is I'm just going to put a little box around this because I get lost without being organized somewhat. Okay, so we're going to take this formula. So we're going to have it equal u times dv, or u times v, I'm sorry. So negative t cosine t minus the integral of v negative cosine du is times just dt. Well, 1 dt if you want to be specific, but yeah. What will happen here, we're going to clean this up a little bit, so I'm going to cancel out these two negatives right here, which will be left with a positive. And something that I do not want to forget as well too is that 2. Don't want to forget that 2. So all we really need to do, I'll clean it up before I do the math on this. So what we have is 2 in brackets negative t cosine t plus the integral of cosine dt. 2 negative t cosine t plus sine This is very important. Glad I caught that. Just re-add our t's. No longer need the dt. Okay, so now from here, after we're done integrating, we're going to put in our 2, so negative 2t cosine t plus 2 sine t plus our constant of integration. However, if we remember, our t is actually equal to square root of x. So what we actually have is negative t square root of x cosine square root of x plus 2 sine square root of x plus c. So that is going to be our final answer for that. So we will move on to part 3 here in a little bit. So thank you.